Hello, this is Evgeny Chivarov, and I'd like to share with you what I have done for my custom project in CS224M class natural language processing. For my custom project, I chose to explore the generation of infrastructure as code artifacts from natural language. And here in the left-hand column, I have a motivating example. In my opinion, cloud today, or more precisely, cloud provisioning, is hard. One way to provision cloud resources today is to go to a graphical user interface such as Azure Portal or similar offerings from AWS or GCP and use those graphical tools to provision the infrastructure desired. However, there are limitations with this approach because only a small subset of infrastructure can be provisioned this way due to inherent complexities involved in configuration. So outside of GUIs, what we can do is we can create a set of what is known as infrastructure as code artifacts, which can be JSON templates, as is in this case of Microsoft Cloud specific example of that artifact. And so those code files essentially define infrastructure to be provisioned and specify the various properties applicable to that infrastructure. As you can see, trying to create those files and manage and maintain them can be a tedious and error-prone task. Additionally, it requires a level of knowledge on both infrastructure and coding side. So can we make things better? I set out to discover if we can make cloud infrastructure provisioning as easy as chatting to a bot, essentially. And so here, if we request an Azure virtual machine with a GPU and PyTorch installed, ideally behind the scenes we would generate being the keyword here, a template that would allow us to easily get that resource in the cloud. So my approach to get us there involved fine-tuning a large pre-trained model, GPT-3 in my case, with Microsoft Cloud specific infrastructure as code data. So Azure Quick Start templates provided a nice subset of about 1,000 templates, which I was able to make use of about 700 of them. Those templates provided both metadata and artifacts to be deployed in the cloud. I augmented this data for my training or fine-tuning purposes using the approach I described in my paper. I used BlueScore to evaluate the performance of my fine-tuned models. In the results, I get about 13% average blue scores across my test set, which consisted of about 576 infrastructure as code samples withheld from training set. And a few observations there. The highest blue scores belong to infrastructure that essentially is self-contained and has very few properties and configuration parameters. Lowest blue scores are associated with a rarely or kind of edge cases of infrastructure where perhaps we haven't seen enough fine-tuning or training data to actually generate those templates appropriately. However, the most common case of essentially provisioning most common resources such as virtual machine storage, networking, fell somewhere in the middle, most likely due to a set of involved configuration parameters that could be associated with each one of those infrastructures. So in conclusion, I believe my efforts showed that generating infrastructure as code using pre-trained large language models is possible, and this could be a very first step towards realizing the goal of actually deploying infrastructure for using natural language instead of creating the JSON files manually. Additionally, large pre-trained language models evolve. Certainly, there will be models specifically trained on code only, and I believe this will result in even higher accuracy of this artifact generation. Thank you.